Okay, guys, let's move on to the next part 4. Numerical Python here. Here's the binomial distribution here. So we need to first we need to use the numerical Python to import random here. It's random method built-in function here, and we can create our x is and use the random method to call the binomial distribution here. So it's a binomial method here, and we can type n, just like n is 10, p is 0.5, psi is 10 here. Okay, the n is the number of 12, and p is probability. The size is the length here. So we can print x. So it prints the array 10 elements here. Yes. So it's the binomial distribution works on the Python here. But if you need to look at the graph, if you want to construct the graph, yeah, I will talk more about it on later videos. I'll show you the other Python library to combine with this numerical Python to construct a graph like the pie chart or something else. So here's the example. Combine two Python libraries to construct the graph. So it's the example here by using the binomial distribution to construct like this graph. And here's the another example here. So I'm gonna use the normal and the binomial distribution. Yeah. So okay. So the next here, I'm gonna teach you Poisson distribution only cover the numerical Python. I just use the numerical Python to introduce this distribution. So how to write the code here? You just put a variable and write and type the random dot Poisson lambda. Lambda is 2, so you just type it out again, and size is 10. Because it only has 2 variables here. If you remember the formula of the Poisson distribution and print it, so it is the outcome here. The lambda, which means the mean here. Yes. Okay, the next one is the uniform distribution. Here. This is random dot uniform. Size is just like the yes. Okay. So the component of the uniform distribution, it has three components. I can show you here. The one of the component is the A, like the A. The A is the A means the lower bound. If you are familiar with this uniform distribution, you should know the lower bound and the upper bound. If I don't mention the A and B, it should be 0.0 by default. 0.0. And the upper bound is the 1.0 by default. And the size, you know, is the length here. See, so it just has three components here. If you could ignore these two, the first two variables. Yeah, but the size you need to mention here. So is the structure of the uniform distribution. Okay, the next is the logistic distribution. Here is like the same, similar structure here. You just type the random dot logistic. The LC means the mean, is the mean, and scale means the standard deviation, and size is just the length here. So 3. Yes, so it's the structure of the logistic distribution. If you, I can recommend that if you wanna learn how to draw the graph, how to print the graph here, you need to learn the matplotlib dot pyplot. And the sequel is to library, Python library first. I will teach the both library in later sessions, and I will go back to this distribution and show you how to draw the graph here. Okay, good. So in this video, I just show you how to learn the numerical Python. Is the basic data science class here. Okay, the next one is the multinomial distribution. The multinomial distribution, it's similar to the previous structures of random dot multinomial, n is 6, EVALS. I will explain later. Okay. Okay, the PVALS. The N means the number of the trials here. So I means the number of the possible outcomes, the results. And the PVALS. This means the probabilities of the outcome. here. If you are familiar with this polynomial distribution, you should know that there are 6 probabilities for the 6 possible outcomes here. Yeah. Also, you could use the size here. You could mention the size like 2 by 5. So here's 2 by 5. The size is optional here. The next is exponential distribution. Here, x is random dot exponential. Scale is the standard deviation. Size only has the scale and size. Yeah. Just like 2 by 5. Poly. Oh, sorry, but the scale is it means the inverse of the rate, so it is 1.0 by default. Yeah. Okay, hold on. So if you don't mention the scale, it's 1.0 by default. Good. And the next here. And the next here is the chi-square fusion. X is random dot chi-square. df means the degree of the freedom. If you are very familiar with this chi-square, you should know what does the degree of the freedom means here. For example, is 2, and the size is just after 2 by 5. Oh, and code and print it. Yeah, so it's the structure of the chi-square, and the next one here is really distribution is R. Here x random dot raygh scale full size is 2 by 5, just for example here. In here the scale means the standard deviation between x. Yeah, if you just learn the numerical Python, you just know how to print the outcomes because it's really easier. It's really easy to memorize each distribution here. They are just a little different from in the arguments here. So the next one is the total distribution. Here, the similar way. Just type the name here. A is 2, just for example, size is 2 by 5. The A means a parameter. Okay, good. And the next here is GF distribution here. So X is random dot GF A is 2. Size is 2 by 5. The A here means the distribution parameter. Here. Okay, so I believe that there's the whole bunch of the distribution you should learn, or just some of the distribution. If you know, you just learn some of the distribution here. So in later, I will teach you how to use the matplotlib and the seaborn to draw the graph like this, for example. So if you just learn the numerical Python, here is really simple, but you can't construct the graph and you can't plot the points. So it's the basic knowledge before you learn learn how to draw the graph in the Python. Yeah. So here's the end of this lesson. Thank you for listening. And the next lesson I'm gonna teach you how to use the function, how to define the function from the numerical Python.